So we're going to start solving linear and absolute value inequalities.
There is one reminder I want to give you guys. Don't forget, when we multiply or divide an inequality, those are the less than, greater than, less than equals to, greater than or equals to, by a negative number, we must switch the inequality. Okay, so we'll do a couple examples just to kind of refresh your memory. So when we're doing the examples of solving linear inequalities, we're going to do it three ways. One, algebraically. One, we're going to use the intersection, and we can do that on our calculator. I'll show you how. And also use the x-intercept method, which we've done before when we were using the zeros to solve for a linear equation. So let's take a look at example 1 first. We have 3x plus 1 greater than or equal to 4x plus 3. It does not matter which x term we move. Let's go ahead and move and subtract the negative 4 from both sides so we can deal with that dividing by a negative. We get negative x plus 1 greater than or equal to 3. Subtract 1 from both sides. We get negative x is greater than or equal to 2. Now we have to divide by that coefficient of negative 1. But when we do, we have to switch the inequality. So we get x is less than or equal to negative 2. Now, this answer here is the inequality. If you're asked to write it in interval notation, it includes negative 2 and everybody to the left. X is smaller than negative 2. So remember, interval notation is always left to right. So it'd be parentheses, negative infinity, all the way to negative 2 with negative 2 included. Sometimes they're going to ask you to graph the solution. So we know that negative 2 works. In the past, we would have put in a colored circle, closed circle at negative 2, and we would shade everybody to the left because x is smaller than that negative 2. If we're using the interval notation, we're going to use the same bracket or parenthesis depending on whether it's included. Ours is included, so we use the bracket negative 2 and still shade to the left. Now, for some of us, if you're still struggling with interval notation, graph it on the number line first and look at the endpoints. It ends here at negative 2, starts way over here at negative infinity. Negative infinity is never included. So we always use parentheses and then everybody in between. So you have your endpoints always left to right. So if that helps you, graph it first, then write your interval notation.
All right, so in example 2, we've got this fraction on both sides. So let's go ahead and reduce that fraction by multiplying both sides by the LCD. Least common denominator of 3 and 5 is going to be 15. On the left-hand side, that 3 can divide into that 15 5 times, giving us the 5 times 2 times the binomial. So that will give us 10 times x minus 4. Less than or equal to, we'll distribute that 15 to both sides. Now, the 5 would divide into that 15 3 times. So distributing that 3, we would get a 9x. But this understood 1 under the 18 just means we multiply that 8 by the 15. So that gives us a negative 120. Distribute on the left, less than or equal to 9x minus 120. Now, a couple of things I want to illustrate here. So I'm going to actually move the x to the right-hand side. So we'll subtract 10x from both sides. There's a method to my madness, trust me. That gives us a negative 40, less than or equal to a negative x minus 120. Go ahead and add that 120 to both sides. That will give us a positive 80, less than or equal to a negative x. And remember, when we divide both sides by a negative, again, that means we're going to switch this inequality, greater than or equals to. So we end up with a negative 80 greater than or equal to x. Now, here's where the problem comes in. A lot of people learned when you're graphing an inequality, we'll put our 0 here and we'll just say negative 80 is there. That we would look at this inequality and it will point to the direction that we would need to shade. That's not the case if x is on the right-hand side. So we know negative 80 is going to be included, but looking at this notation here, the open side is by the negative 8, so negative 80 is the larger number and x is the smaller number. So where are all the numbers that are smaller than negative 80? All of those are to the left towards negative infinity. So our result here would be leftmost would be towards negative infinity, and the rightmost point would be negative 80, and it's included.